So hopefully you were able to work through this problem prior to watching this video, just to make sure that you're able to work through it on your own, or if you made any errors that you are able to resolve those before attempting assignment problems. Statewide study shows that the average Maryland SAT score was 930, population standard deviation of 150. Random sample of 225 Virginia SAT scores shows that the average SAT score was 895. Is there evidence to suggest that the mean SAT Virginia score is lower than the mean SAT score in Maryland? We're going to test at the 5% significance level. We would assume that if there's no variation due to random selection, then the sample mean is going to be equal to the population mean. So we would just expect that the average SAT score to be 930. However, the alternative may suggest, by looking at the problem, that X bar is going to be less than mu. And that's because we read the problem and it says that the score is lower than the SAT in Maryland. We're going to collect some variables. Remember, the variables we need are mu, we need X bar, we need N, we need sigma, and then we need alpha. Mu is the population mean. The population mean is the one associated with Maryland because it does not have a sample size associated with it. So that's going to be 930. Now, there were 225 Virginia SAT scores. So that's a sample size. And remember, we said that if there's a sample size associated with the sample mean, then that's going to be X bar. So in this case, the sample mean is 895. The population standard deviation is 1.50 or 150, excuse me, not 1.50, and the significance level is 5% or 0.05. This is probably the easiest test to do because it's a left tail test. We like left tail tests. We're going to construct the distribution. And our tail, or our range of values, is 0 to 1. And remember, we just set up alpha because it's a left tail test, so we don't have to do anything fancy with it. No, we don't have to split it, we don't have to subtract from 1, etc. We're going to use our formula. Remember, formula is going to be X bar minus mu divided by sigma over square root of n. Notice we put parentheses around both the numerator and the denominator. X bar was found to be 895. That was the Virginia SAT scores. The Maryland SAT scores, 930. Sigma we found to be sigma was 150. And then N, 225. We're going to put parentheses around the numerator, we're going to put parentheses around the denominator, and we're going to throw that into our calculator, and it's going to give us a z-score. Alright, so if you just hold on one moment, I'll type this into my calculator, and make sure that you can type it into your calculator as well. And I got exactly negative 3.5. I'm going to make that negative 3.50 so that way when we look it up, it's much easier to look up on the z-table. Finally, we're going to convert that into our p-value. And again, we get the p-value from the z-table. If we do this, and I'm going to look it up as well, negative 3.50. I got 0.0002. Extremely unlikely. We're going to plot that on the distribution up here. 0.0002 is almost 0. So it probably falls a little bit less than that. So our p-value is 0.0002. And again, we get a reject. All right, so let's type out what our solution means. Since the p-value falls in the reject region, then we reject the null hypothesis. Hence, there is enough evidence to suggest that the mean Virginia SAT score is lower than the mean Maryland SAT score. Great. So hopefully that helps you to be able to see the process for going through and doing this hypothesis test of one mean where the population standard deviation is known. In the next set of videos, what we're going to do is we're going to see what happens when the population standard deviation is unknown.